on, when you see four terms like that, you're always kind of thinking factor by group. And so let me say I'm going to put these two together, and I'll put these two together. Okay, so out of the first two, what's the biggest thing that divides out of x to the fourth and 5x cubed? Well, actually, x3. Don't they both have at least 3 x's? We could actually get 3 x's out of those. And so our leftovers would be x to the fourth, take out 3, would be just 1x. And then 5x cubed, divide out the x cubed, would be 5. Okay, now this one's going to be a little tricky just because right here in the spot in between the two sets of terms there's a subtraction sign. So if you remember, I always want to factor a negative out there. And the biggest thing that divides into 2x squared and 10 and x, right? Okay, so we want the biggest thing. So now if I have negative 2x squared, I'm going to look at this whole thing as negative 2x squared, and I divide out a negative 2x, I would have a negative divided by negative is a positive. We divided the 2 out. Wouldn't there just be an x left over? I kind of know that's what I want because look in the first parentheses. I know those are supposed to match if I do this right. So I could kind of tell what the answer is probably going to be. Then if you look at this plus 10x, a positive 10 divided by a negative 2 would be a negative 5. I had an x, but I divided it out. So there's nothing else left but the negative 5. Now that looks pretty nice, doesn't it? Because there's the x plus 5 in both the parentheses. So let's pull that out. And my leftovers, that's my GCF. And my leftovers is this x cubed minus 2x. Am I done factoring? Normally I would be, right? But not exactly. Because look at the second thing here. Can't I keep going with that second parentheses? Isn't there an x that divides out of x cubed minus 2x? There's an x in each term, right? Okay. So x cubed, take out an x, would leave me x squared. I have a minus 2x, or a negative 2x. I divide an x out, there would be a minus 2. Oh, it did keep going, okay? Now, I can't go any more because if that I had x squared minus 4, that would have been a difference of 2 squares. But 2, this number right here is not a perfect square. So I get to go, yay, I'm done, and say, usually what we do, if we have like an x that's kind of stray like that in the middle, we usually stick it out front. It's just kind of how people normally do things. And then you list your other parentheses. When you put it in the middle, people sometimes accidentally think you're multiplying, so if you stick it out front, it's really clear that that's an x term, not some multiply sign that just ended up getting stuck in there. And so this would be your answer here. Thank you for asking that question, Charlotte. I made a mistake. Up here, negative 2x squared plus 10x. When I take the negative 2x out, positive 10 divided by a negative 2x. Oh, it is a negative, isn't it? Will this one factor then? No, it won't factor. See, I looked right past that. Thank you for noticing this. This one won't factor because those are different. Thank you, Charlotte. Good catch. There is something I should have done that I didn't do, though. It won't make a difference in this part of it. What was the first thing I'm always supposed to check for when I'm factoring? Yeah, did I do that? No. See, it's so hard to remember it. You kind of see a type of problem and your brain just wants to jump in and start doing what it thinks it's supposed to do. First of all, this one won't factor because that is an x plus 5 and an x minus 5. So all this work down here was for nothing because they didn't match up. See how easy it is to make that mistake? I just did it. Okay. Now, the only thing that I could have done here was take a GCF out because this didn't work out for me, did it? So all of this was for nothing, and I could say, okay, I see that it doesn't factor. The only thing I could do is take an x out of each term because there is the GCF of an x. So I could take an x out of everything and it would be x cubed plus 5x squared minus 2x plus 10. I'll put the 10 down here. That's all I can do to factor that because that other expression, even though I forgot to divide it out at first, it would have, if this had factored out correctly, I still could have, kept going and caught my GCF down here. But it just didn't work out. That problem, they set it up on purpose to see if you would catch it, and Charlotte did, and I didn't. Very good, Charlotte. So that one only factors, you can only take an x out of it. They give me this function and they want me to do the factoring and the canceling and basically end up showing the discontinuity and plotting the points. There's a lot of questions here. We'll fit as much of it as we can on the video. They ask us a question, rational function, at the very end, after we go through this all things, they ask us a question, so we might want to be on the lookout for it as we work. Do rational function graphs always have vertical asymptotes? Let's see, okay? First thing I got to do, and it tells me to do this, is factor the numerator and the denominator. Won't 24 divide out of both of the terms on top? So that would be 24 times x minus 2, right? If I factor the top, there's a GCF there, but nothing else going on there. Now on the bottom I have a cube, and if you remember how to factor a cube, I kind of have to think of it as something cubed, so it's x cubed, minus 8 is actually 2 cubed. So I take that x and the 2, and what I do to factor it, I subtract them. I say x minus 2, and then it's square the first term, x squared, multiply the two terms by each other, so this will be a plus 2x, because if you remember the factoring pattern, if there was a subtraction in the first parentheses, the very first operator sign in the second parentheses will be the opposite of what you had there. So it's a plus 2x, or you could look up the formula. And then it's plus the 2 squared is 4. All right. So now, if we've got it factored, what's going to cancel out? Isn't that x minus 2? So that's a whole. Let me go ahead and write it down because they're going to want me to graph this in a minute. So as I find information, I'm going to kind of make a note of it. I have a whole, and to find out where it is, I set that x minus 2, that factor that cancels out. That's a discontinuity, but it's a specific type of discontinuity. It's called a whole. I could solve that, add 2 to both sides. I'd get x equal 2. So if I got a graph, now I know I got a hole in it. Will that bottom factor down there? X squared plus 2x plus 4. Remember how we talked about with cubes that usually that second parentheses doesn't factor? So I'm probably going to want to, in a minute, get my graphing calculator out because we can beat this problem to death, or we can kind of, look and see what we can figure out about it. It asked me, show that the denominator of the simplified fraction is never equal to 0 for any real value of x. If I can't factor it, the only thing I can do with that is go do the quadratic formula. So I'm going to go to a new slide. So here's what I got left. I had h of x is equal to 24, and wasn't that x squared plus 2x plus 4 on the bottom? Okay, if that won't factor, there's nothing I can multiply to get 4, and at the same time it adds up to get 2. They're all positive numbers. Nothing works here. So what I got to do, if I want to show that I can never get that thing to equal to 0, because do you remember that your asymptotes are where the denominator equals 0, the things that don't cancel out? It's where uncanceled factors in the denominator equals 0. So we're just going to say denominator equals 0 just for the sake of brevity here. So if I set that equal to 0, the only way I've got to solve that is the quadratic formula. So here we go. X equal negative b, b is 2. Plus or minus the square root of b squared, 2 squared is 4, minus 4, a is 1, c is 4, all over 2a. Sorry. So a is 1. So 2 times 1 is 2. I'm sorry. Okay, I'm so sorry. I catch y'all's habits. Okay, 4 minus 6. Okay. What's happening under that radical? What is 4 minus 16? Isn't it negative 12? Can I take a square root of a negative number and get a real number? There are no real solutions here because under that radical, there's a negative number. So there's no real solutions. There's only imaginary solutions. And I can't graph imaginary numbers. So I can't ever, the answer to part B is it's never going to equal 0 because there's not any real number solution. So what we just did was show that with the quadratic formula since we couldn't factor it. Now they want us to calculate points and plot the graph showing all discontinuities. This one doesn't even have a vertical asymptote, does it? There is no vertical asymptote here because there is no place where the denominator was equal to 0. There will be, and we'll learn about this later on, there will be a horizontal asymptote, and there's even such things as slant asymptotes, which again we'll learn about that later. So all I can really do to graph this thing, are there even any x-intercepts here? How do you find the x-intercepts? Remember? Remember that you set the numerator equal to 0 to find an x-intercept? Let me write that down here. To find an x-intercept, you set the numerator equal to 0, anything that didn't cancel out. If I set 24 equals 0, does that make sense? That's not equal either. So there's no x-intercepts. There's no vertical asymptote. There's no x-intercepts. This is going to be one of those problems that really, in order to graph it, you're either going to have to take by hand and plug in a bunch of numbers or go to your table of values in your calculator. I would suggest go to your table of values in your calculator and kind of look at what this looks like. If you bring this up on your calculator, I'm going to do that right now. Okay, so you could, again, what they want you to do is pick some good numbers. I'm just going to generally show you, if you go to the calculator, this is what your graph looks like. It's going to come up here, it's going to do something like this. Actually, it peaks before the x-axis, and then it comes down and does something like this. This graph has a horizontal asymptote of the x-axis if you look at it, but it doesn't even have a vertical asymptote. So not all rational equations have vertical asymptotes, and that's what they ask you in D. So the answer to D, rational function graphs always have vertical asymptotes, is false. What's funny about that is almost every textbook I've seen, other than this one, never asks you that question, and they never give you examples of anything that don't have vertical asymptotes. So he's trying to be very thorough here in the questions that he asks us. Most of the ones that we usually study do, but this one doesn't, and it's because, there's no factors in the denominator that actually you can get to equal 0, even if you use the quadratic formula.